In this video, we demonstrate our interactive tool and its usage. Given the SAE feature data and concept data, users can adjust a threshold to load concept-relevant features. The bar chart shows the percentage of discovered concepts across model layers. By clicking on a layer, the features in that layer are visualized below. On the left, we show the number of features for each concept category. In the middle, we show a UMAP and a ball mapper overview. Selecting a category will show its overlap with other categories, and relevant features highlighted in both ball mapper and UMAP. Users can hover over each point to see its explanations. Clicking on a point highlights its nearby neighbors by green color. For example, this feature is about grapes, and its neighbors relate to fruit and sugar. The corresponding node in the ball mapper is also highlighted. Below, the feature details show in a card, and clicking the explanation links to the feature page in NeurIPS. Users can also select a mapper node. Here, the two features in this node are nearest neighbors, but they appear distant in the UMAP view, due to dimensionality reduction distortion. Users can anchor the layout with UMAP to better align with the UMAP view, or towards a force-directed layout for clearer topology. Besides, users can query a concept such as apple. The relevant features are highlighted in UMAP. This example, the feature is about the Apple company and its neighbors related to concepts of fruit. In the early layer, both UMAP and ball mapper show no clear structure. When selecting a category food, the relevant features are randomly distributed in the visualization. We can pin this category and then select another one for comparison. Once selected, UMAP and ball mapper use color to distinguish shared and unique features. For example, food shows strong overlap with fruit. Food has clearer distinction from electronic device, but no separation is shown on the visualization. In the middle layer, the two views form two clusters, but food and electronic device still lack a clear boundary in the visualization. By the later layer, UMAP and ball mapper appear as a single cluster again, while food and electronic device become more separated. Each category also becomes more concentrated, forming dense regions. For example, in this region, mapper node corresponds to candy and desserts, while this region contains features about audio and musical equipment. At the boundary between food and electronic device, the mixed node captures features such as toasters and kitchen appliances. Now we switch to subject concepts and load the relevant features. Unlike the Things Plus data, there is no clear global separation across layers. In this layer, the features are largely dominated by computer science. We compare computer science with mathematics, and for a clearer view, we adjust the mapper parameters to recompute. In this view, notice a chain that transitions from mathematics to computer science. It begins with geometry and circle. Then it shifts to features that are relevant to circular, circle, and chain. And finally to chain and threading in programming, showing a smooth transition from mathematical terms to computer science terms. Thank you for watching. Please refer to our paper for details.